Hello, in this lecture we will find the radius of the small circle. In the drawing we have a quarter circle and we know that angle BCD equals to 90 degrees, and inside the quarter circle we have this small circle, and we also know that chord CD equals to 2 units. OD actually equals to 3 units, but because of the fact that we have a quarter circle, OD is actually the radius of the quarter circle. So OD will be defined as capital R, that is to say, is the radius of the quarter circle, and also angle DOB. This angle is a right angle, it equals to 90 degrees. Because of the fact that we have a quarter circle, this angle must be equal to 90 degrees. Okay, so let's define the center of the small circle as P. So this center of the small circle will be defined as P, and we will join together points A and P by a straight line. Actually, AP is the radius of the small circle. We will define it as small r, and we will connect together points P and B by a straight line, and actually angle PAB is a right angle. It equals to 90 degrees because of the fact that BA is tangent to the small circle at point A, and we have the radius of the circle at point A. So we have the rule that states that the radius and or the tangent to the radius, the tangent to the radius and the radius are perpendicular to each other. Again, the rule is that the tangent to the radius and to the circle also, and the radius are perpendicular to each other. So if we have a circle and this is the center of the circle, and we have radius. This is the radius, and we have tangent to the circle and to the radius also. Then the tangent AB is perpendicular to the radius, that is to say this angle equals to 90 degrees. Okay, so the radius and the tangent to the radius and to the circle are perpendicular to each other, that is to say the radius is perpendicular to the tangent, therefore this angle equals to 90 degrees. Okay, so actually in the drawing we have tangent AB. AB is tangent to the small circle at point A, and we have PA, that is the radius of the small circle, and according to the rule that the radius and the tangent to the radius and to the circle are perpendicular to each other, angle PAB equals to 90 degrees. Okay, and we will define angle ABP as theta. So this angle equals to theta, and actually tangent theta equals to AP over AB. Okay, tangent theta equals to AP over AB. But we know that AP is the radius of the small circle, so it equals to small r. Small r over AB, so we have the equality that states that tangent theta equals to r over AB. We will multiply this equality by AB, and we will get that r, the radius of the small circle, equals to AB times tangent theta. Okay, so actually in order to find out the radius of the small circle, we have to find out the value of AB, and we also have to find out the value of tangent theta. After we find out the values of AB and tangent theta, we will multiply one by each other, one by the other, and we will get the radius of the small circle. Okay, so we will define the actually line segment CB is tangent to the circle, to the small circle. At this point we will define this point as point X. The touching point between CB, line segment CB and the circle is point X. So in the next step we will join together points P and X by a straight line. Px is actually the radius of the small circle because of the fact that it exits from the center of the circle and it ends at point X, that is a point on the circle itself. Therefore Px is the radius of the small circle. So actually we have here two right triangles. This angle is also equals to 90 degrees because CB is tangent to the radius and to the circle itself, therefore this angle is 90 degrees. So actually we will prove that triangles ABP and triangle A and triangle PBX are congruent to each other. So I will draw again those two triangles. So I draw again triangle APB and triangle PBX. We'll prove that those two triangles are congruent to each other. Actually, we know that AP is the radius of the circle and also PX is also the radius of the circle. So AP equals to PX, and both those two line segments are the radiuses of the small circle, therefore they are equal to each other. And also PB is a common side, it belongs to the right triangle APB, and PB also belongs to the right triangle PBX. So PB equals to PB. It is actually a common side. And also AB equals to BX. AB equals to BX according to two tangent theorem. Two tangents theorem. So what is two tangents theorem? Actually, two tangents theorem two tangents theorem states that the lengths of two tangents from common external point to a circle are equal. So I will read two tangents theorem again. Two tangents theorem states that the lengths of two tangents from common external point to a circle are equal. So actually in the drawing itself we have two tangents to the small circle. We have tangent AB that is tangent to the small circle at point A, and we have tangent BX that is tangent to the circle at point X. So those two tangents exiting from external point, from common external point, from point B, and they touching the circle at points A and X. So according to two tangents theorem, the lengths of those two tangents are equal. That is to say, AB equals to BX. Okay, so if you have two tangents that are exiting from a common external point, and the tangent to the circle, then the lengths of those two tangents will be equal to each other. So AB equals to BX. Therefore, we actually proved that all the sides of triangle PBX are congruent to all the sides of triangle APB. Therefore, triangle APB is congruent to triangle PBX according to side rule. So I will read again the things that I wrote. Triangle APB is congruent to triangle PBX according to side rule. So actually the meaning of side rule is that if you have one triangle that all of its sides are congruent to another triangle, then those two triangles congruent to each other according to side rule. Okay, so we proved that those two triangles are congruent to each other. Therefore, we can derive from it that angle ABP that equals to theta equals to angle PBX, to this angle PBX. So angle PBX also will be equal to theta. And so angle ABP equals to angle PBX, and both those two angles are equal to theta, according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, again, it is according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, so those two angles are both equal to theta. Okay, so in the next step we will extend line segment CB and the radius DO until they intersect with each other at point E. Okay, so we will extend line segment CB and the radius DO until they intersect with each other, and the intersection point will be defined as point E. Again, point E is the intersection point between CB and the radius DO. Okay, so actually by extending those two line segments we created two vertex angles. Actually, angle EBO, this angle, and angle ABC are two vertex angles. Again, angle EBO and angle ABC are two vertex angles. So I will draw them again in order to see it clearly. Angle EBO and angle ABC actually angle ABC and angle EBO are two vertex angles, and we have a rule that states that vertex angles are equal to each other. Vertex angles are equal to each other. That is to say, angle ABC, this angle, is equal to angle EBO. So both those two angles are equal to each other. And what is the size of angle ABC? Angle ABC is the angle that I marked in the red color. So angle ABC is equal to theta plus theta, that is to say to 2 theta. Okay, so angle ABC equals to 2 theta. So from this equality we can derive that angle EBO, from this equality we can derive that angle EBO also equals to 2 theta. So this angle EBO equals to 2 theta. Okay. So actually angle ECD equals to 90 degrees. Again, angle ECD equals to 90 degrees. And angle ECD is a peripheral angle. Because of the fact that angle ECD is inside the quarter circle, angle ECD is a peripheral angle. Okay, and we have a rule that states that any peripheral angle that equals to 90 degrees rests on the diameter of the circle. Okay, so I read the rule again. The rule states that any peripheral angle that equals to 90 degrees rests on the diameter of the circle. So actually, peripheral angle ECD that equals to 90 degrees rests on ED. So ED is the diameter of the quarter circle according to the rule that I read 1 minute ago. So the rule states that any peripheral angle that equals to 90 degrees rests on the diameter of the circle. So peripheral angle ECD equals to 90 degrees, therefore it rests on the diameter of the circle. So peripheral angle ECD that rests on ED rests on the diameter of the circle. That is to say, ED is the diameter of the quarter circle. Okay, so according to this rule, we can derive from this rule that ED is the diameter of the quarter circle. Okay, ED is the diameter of the quarter circle, and we know that the diameter of any circle equals to 2 times the radius of the circle. So actually the diameter ED equals to 2 capital R. The diameter ED equals to 2 times capital R, but we have already found out that DO equals to capital R, so OE must be equal to R in order that ED will be equal, in order that ED will be equal to 2R, OE must be equal to R, because we will get that R plus R equals to R, okay? So OE equals to capital R, and R equals to 3 units, so equals to capital R, that equals to 3 units. Okay? So we know that DE is the diameter of the quarter circle. So first, before that, we will complete the quarter circle to a semicircle. So actually, DE is also the diameter of the semicircle. DE is the diameter of the semicircle. It is a straight line, okay? DE is a straight line because it is the diameter of the semicircle. DE is a straight line. DE is a straight line, and we have a rule that states that the sum of the angles on a straight line equals to 180 degrees. The sum of the angles on a straight line equals to 180 degrees. Okay, I read the rule again. The rule states that the sum of the angles on a straight line equals to 180 degrees. So we know that DE is a straight line. Therefore, if we focus at point O, the sum of the angles must be equal at point O on the straight line DE to 180 degrees. So what we have at point O, we have this angle POB that equals to 90 degrees. And we have also angle EOB and according to the rule that I read, the sum of those two angles must be equal to 180 degrees. Okay, so if we subtract from this equality 90 degrees, we will get that angle EOB equals to 180 degrees minus 90 degrees equals to 90 degrees. Okay, so angle EOB is a right angle, that is to say it equals to 90 degrees. Okay, so if angle EOB equals to 90 degrees, if it is a right angle, then triangle EOB is a right triangle. This triangle EOB is a right triangle, and anyway we know that the sum of the angles in triangle EOB equals to 180 degrees, that is to say 90 degrees plus 2 theta plus the side of angle OEB plus the size of angle OEB must be equal to 180 degrees. Okay, again 90 degrees plus 2 theta plus angle OEB must be equal to 180 degrees. So we subtract 90 degrees from this equality and we will get that 2 theta plus angle OEB equals to 180 degrees minus 90 degrees is 90 degrees. Okay, we got the equality that states that 2 theta plus angle OEB equals to 90 degrees. Here we'll subtract from this equality 2 theta and we will get that angle OEB equals to 90 degrees minus 2 theta. Okay, so we found out that angle OEB this angle equals to 90 degrees minus 2 theta. In the next step we will focus on the right triangle CDE. So in the right triangle CDE, we know that the sum of the angles is equal to 180 degrees. So actually the size of angle EDC plus 90 degrees plus this angle that equals to 90 degrees minus 2 theta must be equal to 180 degrees. Okay, so in triangle EDC the sum of the angles is equal to 180 degrees. So actually in this side of the equality we have 90 degrees plus 90 degrees is 180 degrees, and the other side of the equality we have also 180 degrees. So 180 degrees will be cancelled on both sides of the equality. So here what is left is 0. So actually after we cancel 180 degrees, what is left is that angle EDC minus 2 theta equals to 0. We cancel 180 degrees, so here we have 0. So we will add 2 theta to this equality and we will get that angle EDC equals to 2 theta. Okay, angle EDC equals to 2 theta. Okay, so this angle EDC equals to 2 theta. Okay, so we will continue to focus on the right triangle EDC, because of the fact that triangle EDC is a right triangle. We can implement the Pythagoras theorem on the right triangle EDC. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, CD square plus EC square equals to DE square. Okay, CD square plus CE square equals to DE square. Again, in the right triangle CDE, we implemented the Pythagorean theorem. We got that CD square plus CE square equals to DE square. What is the value of CD? CD equals to 2 units. It is given us in the question. So CD square is 2 square, 2 square is 4, plus CE square equals to DE square. What is the value of DE? DE equals to R plus R. It is the diameter of the semicircle. R equals to 3, so R plus R is 3 plus 3 is 6. And DE square is 6 square, 6 square is 36. So in total we got that 4 plus CE square equals to 36. Here we will subtract 4 from this equality and we will get that CE square equals to 36 minus 4 is 32. Okay, so here we will take a root out of this equality and we will get that CE equals to the root of 32. But we know that 32 is 16 times 2. So it equals to the root of 16 times 2. The root of 16 is 4. So in total we got that CE equals to 4 times root 2. Okay, again, CE equals to 4 times root 2. We found out that CE equals to 4 times root 2. Okay, what is the value of in triangle CDE, the right triangle CDE? What is the value of tangents 2 theta? Tangents 2 theta equals to CE over CD. Okay, tangents 2 theta equals to CE over CD. Okay, so we know that the value of CD is 2. And we have already found out that CE equals to 4 times root 2. So actually tangents 2 theta equals to CE, that is 4 times root 2 over CD, that is 2 units. It is given us in the question. So 4 times root 2 over 2. So 4 over 2 is 2. So in total we get that tangents 2 theta equals to 2 times root 2. Again, tangents 2 theta equals to 2 times root 2. Okay, we actually found out that the radius of the small circle equals to AB times tangents theta. So we have to find out the value of tangents theta. Okay, in order to find out the value of tangents theta from tangents 2 theta, I will present to you a new trigonometric identity and we will find out the value of tangents theta from the new trigonometric identity. The trigonometric identity is tangents 2 theta equals to 2 tangents theta over 1 minus tangents square theta. Okay, so that is the trigonometric identity. We have already found out that tangents 2 theta equals to 2 times root 2, so we can substitute tangents 2 theta in the trigonometric identity by 2 times root 2. Okay, so here we write down 2 times root 2 equals to 2 tangents theta over 1 minus tangents square theta. Okay, so two times root 2 equals to 2 tangents theta over 1 minus tangents square theta. Here we will define tangents theta as x, and we will solve this equality. So tangents theta is defined as x. We will substitute tangents theta as x in this by x in this equality. We will get that 2 times root 2 equals to 2 tangents theta is 2x over 1 minus tangents theta square is x squared. Okay, so here we will multiply this equality by 1 minus x squared, or we will cross multiply this expression. So we will get that 2 times root 2, in the brackets we will have 1 minus x squared equals to 2x. So here we will divide this equality by 2. We will get that root 2, 1 minus x squared equals to 2x. Can we divided this equality by 2, so 2x over 2 is x. So here we will open the brackets. In this side of the equality we will get that root 2 minus root 2x squared equals to x. So here we will add 2x root 2x root 2 times x squared to this equality, and we will get that root 2 equals to root 2 x squared plus x. Okay, so we got this quadratic equation. We will subtract root 2 from this equality. We will get that root 2 x squared plus x minus root 2 equals to 0. So we have quadratic equation. The general formula for quadratic equation is ax squared plus bx plus c equals to 0 when a, b, and c, ax squared plus bx plus c equals to 0. A, b, and c are the coefficients of this quadratic equation, and the x is the variable that we want to find out, and we will find out the variable x by using a special formula for x. X equals to minus b plus minus root of b squared minus 4 times a times c over 2 times a. Okay, so a, b, and c in this formula are the coefficients of the quadratic equation. And in our specific quadratic equation, we know that a equals to root 2, b equals to 1, and c equals to minus root 2. Okay, so we will put the data inside the x in order to find out the value of x. So x will be equal to minus b. B is 1, so minus b is minus 1 plus minus root of b square. B is 1, b square is 1 square is 1, minus 4 times root 2 times minus root 2 over 2a. 2a is 2 times root 2. So we got that x equals to minus 1 plus minus root of 1. First of all, minus times minus is plus. Root 2 times root 2 is 2, and 2 times 4 is 8. 2 times 4 is 8. And 4 plus 1 is 9. So in the root we have 9 only over 2 times root 2. Okay, so we got that x equals to minus 1 plus minus root 9 over 2 times root 2. Root of 9 is 3, so I write it down. So we get that x equals to minus 1 plus minus 3 over 2 times root 2. So we have here two solutions. The first solution will be x equals to minus 1 minus 3 over 2 times root 2. It equals to minus 1 minus 3 is minus 4 over 2 times root 2. So minus 4 over 2 is minus 2 over root 2. So we found out that x equals to minus 2 over root 2. So x is negative number, is less than 0, it is a negative number. Or in other words, x equals to tangent theta. So tangent theta is negative. Tangent theta is negative. Okay? But actually, we have the right triangle APB. In the right triangle APB, in the right triangle APB, we have angle ABP is theta. This angle is 90 degrees. So actually, angle APB plus theta equals to 90 degrees. Angle APB plus theta equals to 90 degrees. That is to say, angle theta equals to 90 degrees minus the size of angle APB. 90 degrees minus the size of angle APB is less than 90 degrees. So we found out that angle theta is less than 90 degrees. Angle theta is less than 90 degrees, and if angle theta is less than 90 degrees, tangent theta must be a positive number. Tangent theta is greater than 0. But according to the solution that we found out that tangent theta actually equals to minus 2 over root 2. That is a negative number, is less than 0. So there is a contradiction, because according to what we found, tangent theta must be a positive number. We found out that tangent theta is a negative number. Therefore, this answer is incorrect answer, and we left only with the answer that x equals to minus 1 plus 3 over 2 times root 2. Minus 1 plus 3 is 2, and 2 over 2 times root 2 is actually 2 over 2 is 1 over root 2. So we found out that x equals to 1 over root 2. Here, tangent theta is a positive number, so it is okay. So, and x equals to tangent theta, so tangent theta equals to 1 over root 2. Okay? And we have already found out the tangent 2 theta equals to 2 times root 2. Okay? So we will focus on triangle BOE. So in triangle BOE, the small triangle, the small right triangle BOE, tangents 2 theta equals to OE over OB. Okay? In triangle, the right triangle BOE, tangents 2 theta equals to OE over OB. But what is the value of OE? OE equals to 3 units. Okay, OE equals to 3 units. And OB is OB. And we have already found out that tangent theta equals to 2 times root 2. So we found out that tangent theta equals to 3 over OB. Tangent 2 theta equals to 3 over OB. We've already found out that tangent 2 theta equals to 2 times root 2, so we will substitute tangent 2 theta by 2 times root 2 equals to 3 over OB. So here we will multiply this equality by OB, and then we will divide it by 2 times root 2. We will get that OB will be equal to 3 over 2 times root 2. Okay, so we found out that OB equals to 3 over 2 times root 2. So OB equals to 3 over 2 times root 2. Okay. In the next step, we will join together points P and O by a straight line. Join together points P and O by a straight line. Then actually triangle APO is a right triangle, PO is the hypotenuse. We will extend the hypotenuse until it touches the two circles at point M. Okay. We extend that the hypotenuse OP until it touches the two circles at point M. Point M is actually the touching point between the semicircle to the small circle, and it also the point that the hypotenuse OP extended to. Okay, so what is the value of OP? The value of OP is actually equals to OM minus MP, equals to OM minus MP. And OM is the radius of the semicircle, because it starts from the center of the semicircle and ends at point M, that is the point of the semicircle itself. So OM equals to capital R. And MP is the radius of the small circle, because of the fact that it starts from point P, that is the center of the small circle, and ends at point M, that is the point on the small circle itself. So all MP is small r. Okay, so OP equals to capital R minus small r. But we know that capital R equals to 3. The radius of the semicircle equals to 3. So in total we found out that OP equals to 3 minus small r. Okay, OP equals to 3 minus small r. Okay, so we know that triangle APO is a right triangle because of the fact that angle OAP is a right angle, therefore triangle APO is a right triangle. So we can implement the Pythagorean theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say AP square plus AO square equals to OP square, that is the hypotenuse squared. Okay, so in the right triangle triangle APO, according to the Pythagorean theorem, AP square plus AO square equals to OP square. What is the value of AP? AP equals to small r. It is the radius of the small circle, so AP square is r square. And AO is AO square equals to OP square. What is the value of OP? We have already found out that the value of OP is 3 minus r. So OP square is 3 minus r square. So in total we found that r square plus AO square equals to 3 minus r square. Here we will open the brackets on this side of the equality, and we will get that r square plus AO square equals to 3 minus r square is 9 plus r square minus 6r. So here we have r square on this side of the equality and we have r square on the other side of the equality, so we will cancel r square. R square will get cancelled. And what is left after we cancelled r square is AO square equals to 9 minus 6r. We will take a root out of this equality and we will get that AO equals to the root of 9 minus 6r. Okay, so again we found out that AO equals to the root of 9 minus 6r. AO equals to the root of 9 minus 6r, and we have already found out that OB equals to 3 over 2 times root 2. 3 over 2 times root 2. Okay, so we found out the values of AO and OB. And what is the value of AB? The value of AB equals to AO minus BO. Okay, AO minus BO equals to AB. Again, AB equals to AO minus BO. And we've already found out the values of AO and BO. BO and OB it is the same. So we will substitute AO by root 9 minus 6r, and we will substitute OB or BO, which is the same. We will substitute BO by 3 over 2 times root 2. So AB will be equal to AO is the root of 9 minus 6 small r minus BO. BO is 3 over 2 times root 2. Okay, so we have the value of AB, and we have already found out that tangent theta equals to 1 over root 2. Okay, tangent theta equals to 1 over root 2, and AB equals to this expression. So again we know that what is the radius of the small circle? The radius of the small circle equals to AB times tangent theta. Again, the radius of the small circle equals to AB times tangent theta. We have already found out the value of AB. This is the value of AB, and we have already found out the value of tangent theta equals to 1 over root 2, so we will substitute AB by its value, and we will substitute tangent theta by 1 over root 2. Okay, so the radius of the small circle will be equal to AB. AB is the root of 9 minus 6r minus 3 over 2 times root 2, and the value of tangent theta is 1 over root 2. So r equals to AB times tangent theta. AB is this expression, and tangent theta is 1 over root 2. So here we will multiply this equality by root 2. We will get that root 2 times r equals to root of 9 minus 6r minus 3 over 2 times root 2. So here we will add to this equality 3 over 2 times root 2, and we will get that 3 over 2 times root 2 plus root 2 times r equals to the root of 9 minus 6r. So here we will multiply root 2r by 2 times root 2, and then we will divide it by 2 times root 2 in order to have a common factor with 3 over 2 times root 2. Okay, so root 2 times r times 2 times root 2 over 2 times root 2 plus 3 equals to the root of 9 minus 6r. Okay? So here we have root 2 times root 2 is 2, and 2 times 2 is 4. So in total we will have here in the numerator 4r plus 3 over 2 times root 2 equals to the root of 9 minus 6r. Okay? So here we will square this equality. We will square both sides of this equality, and we will get that 4r plus 3 square, 2 times root 2 square is 8, equals to the root. Here we have root and square. The square, the function square cancels the root. So in total what is left is only 9 minus 6r, because the square cancelled the root. So we left with only 9 minus 6r. So here we will multiply this equality by 8. We will get that 4r plus 3 square equals to 9 times 8 times 9 is 72, and 7 times minus 6r is minus 48r. Here we will open the brackets this side of the equality. 4r plus 3 square equals to 16r square plus 9 plus 4 times r is 12r. 12r times 2 is 24r equals to 72 minus 48r. Here we will add to this equality 48r, and we will get that 16r square plus 9 plus 28 times 28r plus 48r is 72r equals to 72. Here we will subtract 72 from this equality, and we will get that 16r square plus 72r, 9 minus 72 is minus 63 equals to 0. So we got quadratic equation So in this quadratic equation, a equals to 16, the coefficient of the quadratic equation, b equals to 72, and c equals to minus 63. And the general solution for any quadratic equation is x equals to minus b plus minus the root of b squared minus 4 times a times c over 2a, when a, b, and c are the coefficients of the quadratic equation, and x is the variable that we want to find out. In our specific quadratic equation, the variable that we want to find out is r. So x equals to r equals to minus b. b equals to 72, so minus b is minus 72 plus minus root of b squared. b equals to 72, so b squared is 72 squared, and 72 squared is 5,184 minus 4 times a, 4 times 16 is 64, and 60 minus 64 times minus 63 is 4,032 over 2a. a equals to 16, so 2a is 32. So in total we got that r equals to minus 72 plus minus the root of 5,184 plus 4,032 equals to 9,216 over 32. So we will get that r equals to minus 72 plus minus the root of 9,216 is 96 over 32. So in total we have here two solutions for r, or two roots for r. The first solution is that r equals to minus 72 plus 96 over 32. Minus 72 plus 96 is 24, and 24 over 32 is 3 over 4, or 0.75 units. So we found out that the radius of the small circle equals to 3 over 4 units, or 0.75 units. Okay. But we have also the second solution. The radius, according to the second solution, equals to minus 72 minus 96 over 32. It is actually equals minus 72 minus 96 is minus 168 over 32 is minus 5.25. So the radius equals to minus 5.25, but the radius must be a positive number, so r cannot be negative, so this solution is incorrect, and we left only with the solution that the radius of the small circle equals to 3 over 4 units, or 0.75 units. Okay, again, the radius of this small circle equals to 3 over 4 units, or 0.75 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the radius of this small circle. The small circle is inside a quarter circle. We know that line segment CD equals to 2 units. We know that OD, that is actually the radius of the quarter circle, equals to 3 units. And we also know that angle BCD equals to 90 degrees. And we want to find out the radius of the small circle. Okay, so first of all, as I have already told you, DO is the radius of the quarter circle, therefore it defined as capital R. So the radius of the quarter circle equals to 3 units. And because of the fact that we have a quarter circle, angle DOB equals to 90 degrees. Okay, so we actually defined the center of the small circle as point P. Then we joined together points A and P by a straight line. Actually, AP is the radius of the small circle because of the fact that it starts from the center of the small circle, that is to say from point P, and ends at point A, that is a point on the small circle itself. Okay, then we also join together points P and B by a straight line, and we join together also point P and X by a straight line. X is the touching point between CB and the small circle. And PX is actually also the radius of the small circle. Okay, so then we actually before that we have a rule that the tangent to the radius and the radius are perpendicular to each other. So actually, if we have this circle and this is the radius of the circle, and AB is tangent to the circle at point B, then the radius and the tangent perpendicular to each other, that is to say this angle is 90 degrees. Okay, so here we have the tangent AB. AB is tangent to the small circle at point A, and we have the radius AP, and according to the rule that I stated, the tangent AB is perpendicular to the radius AP, therefore this angle is 90 degrees. Angle PAB equals to 90 degrees, and we defined angle ABP as theta, and actually tangent theta equals to AP over AB. Okay, tangent theta equals to AP over AB, but we know that AP is the radius of the small circle, so tangent theta equals to R over AB. We multiply this equality by AB, and we got that R equals to AB times tangent theta. So here we need to find out the value of AB and the value of tangent theta in order to find out the radius of the small circle. Then we proved that triangle PBX is congruent to triangle ABP. First of all, AP equals to PX. AP equals to PX. Both of those two line segments are the radiuses of the small circle, therefore they are equal to each other. PB equals to PB. PB is common side. It belongs to triangle BBX, and it also belongs to triangle APB. And we also know that AB equals to BX according to two tangents theorem. And the two tangents theorem states that the lengths of two tangents from a common external point to a circle are equal. So actually, if we have two tangents to a circle from a common point, that is to say from point B, we draw two tangents to the small circle, that is to say tangent AB and tangent BX, then those two tangents have the same size, that is to say AB equals to BX. So we actually proved that all the sides of triangle APB are congruent to all the sides of triangle PBX. Therefore, we proved that those two triangles are congruent to each other, and therefore, if angle ABP equals to theta, angle BX, angle PBX will be also equal to theta, because of the fact that corresponding angles in congruent triangles are equal to each other. So those two angles are both equal to theta. Okay. And then, so actually angle APB equals to angle PBX, both those two angles are equal to theta. And then we extended line segment CB and the radius DO, we extended them until they intersect with each other at point E. And in this way we created two vertex angles. Actually, angle ABC and angle EBO are two vertex angles, and we have the rule that vertex angles are equal to each other, so angle ABC equals to angle OEB according to this rule. So angle ABC equals to angle EBO, but we know that angle ABC equals to theta plus theta, so angle ABC equals to 2 theta, therefore angle EBO, from this equality we can derive that angle EBO also equals to 2 theta. So this angle EBO equals to 2 theta. Okay, then we have angle ECD is a peripheral angle, because of the fact that it is inside the quarter circle, and we have a rule that any peripheral angle that equals to 90 degrees rests on the diameter of the circle. Therefore, we know that angle ECD equals to 90 degrees. So according to the rule, the peripheral angle ECD equals to 90 degrees. According to the rule that is stated, angle ECD rests on the diameter of the circle. That is to say, it rests on ED, that is the diameter of the quarter circle. Okay? According to the rule that I stated, ED is the diameter of the quarter circle. And we know that the diameter of any circle equals to 2 times the radius of the circle. So if DO equals to R, then OE must be also equal to R in order that DE will be equal to 2R. Because if this equals to R, OE must be also equal to R in order to complete the size of DE to 2R. So OE equals to R, and we know that DE as the diameter of the circle is a straight line, and we have a rule that the sum of the angles on a straight line equals to 180 degrees. So if we focus on the straight line DE at point O, we know that the sum of the angles at point O, the straight line DE equals to 180 degrees. We have already found out that this angle DOA equals to 90 degrees. So 90 degrees plus the size of angle BOE must be equal to 180 degrees according to the rule that I stated. So 100 degrees plus angle EOB equals to 180 degrees. We subtracted 90 degrees from this equality and we got that angle EOB equals to 90 degrees. So this angle equals to 90 degrees, therefore triangle EOB is a right triangle. Okay? And we found out, we know that the sum of the angles in any triangle equals to 180 degrees, so 90 degrees plus 2 theta plus the size of this angle must be equal to 180 degrees. 90 degrees plus 2 theta plus angle OEB must be equal to 180 degrees. From this equality, we got that angle OEB, this angle equals to 90 degrees minus 2 theta. And we know also that the sum of the angles in the big right triangle CDE must be equal to 180 degrees. So the size of this angle plus 90 degrees plus this angle that equals to 90 degrees minus 2 theta must be equal to 180 degrees. Okay? And so from this equality, we got that angle EDC, this angle equals to 2 theta. Because of the fact that triangle CDE is a right triangle, we can implement the Pythagorean theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, CD square plus CE square equals to DE square. Okay, CD square plus CE square equals to DE square. CD equals to 2, so CD square is 2 square is 4, plus CE square equals to DE square. DE is the diameter of the semicircle, therefore it equals to 2R and R equals to 3, so 2R is 6. So DE square is 6 square, 6 square is 36. So we got that 4 plus CE square plus 4 plus CE square equals to 36. We subtracted 4 from this equality, and we got that CE equals to 4 times root 2. Okay, CE equals to 4 times root 2, and in triangle CDE, the right triangle CDE, tangents 2 theta equals to CE over CD. Tangents 2 theta equals to CE over CD. We found out that CE equals to 4 times root 2 and CD equals to 2 units. It is given us in the question, so 4 times root 2 over 2 is 2 times root 2. So tangent 2 theta equals to 2 times root 2. And we know that the radius of the small circle equals to AB times tangent theta. We have only the value of tangent 2 theta, so in order to find out the value of tangent theta, I presented to you a new trigonometric identity that states that tangent 2 theta equals to 2 tangent theta over 1 minus tangent square theta. And we know that tangent 2 theta equals to 2 times root 2, so we substituted tangent 2 theta by 2 times root 2, and we got to this equality that 2 times root 2 equals to 2 tangent theta over 1 minus tangent square theta. We defined tangent theta as x, so we substituted tangent theta in this equality by x, and we got to a quadratic equation. We had the quadratic equation that root 2 times x squared plus x minus root 2 equals to 0. We solved this quadratic equation and we found out that x equals to 1 over root 2. X equals to 1 over 2, but x is tangent theta, so tangent theta equals to 1 over root 2. And we have already found out that tangent 2 theta equals to 2 times root 2. Okay, so in triangle, the right triangle BOE, we know that tangent 2 theta equals to OE over OB. But we know that OE equals to 3 units. Okay, triangle BOE, tangent 2 theta equals to OE over OB. OE is the radius of the semicircle, it equals to 3. So it is 3 over OB. But we have already found out that tangent 2 theta equals to 2 times root 2. So we substitute the tangent 2 theta by 2 times root 2. And from this equality we got that OB equals to 3 over 2 times root 2. Okay, OB equals to 3 over 2 times root 2. And then we connected together points P and O by a straight line. Therefore, we got the right triangle, triangle APO. It is a right triangle because angle OAP equals to 90 degrees. So in the right triangle OAP, we extended the hypotenuse OP until it touches the circle at point, until it touches the two circles at point M. Point M is actually the touching point between the small circle with the semicircle, and it is also the point that OP arrived to until we after we extended OP until point M. So what is the value of OP? OP actually equals to MO, that is the radius of the semicircle that equals to 3 units, minus MP, that is the radius of the small circle. So it equals to capital R minus small r. Capital R equals to 3. So capital R minus small r is 3 minus small r. Or OP equals to 3 minus small r. Okay, and we implemented the Pythagorean theorem on the right triangle, triangle APO. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AP square plus AO square equals to PO square. AP square plus AO square equals to PO square. We know that AP is the radius of the small circle, so AP square is small r square plus AO square equals to OP square. OP equals to 3 minus small r. So OP square equals to 3 minus small r square. From this equality we found out that OA equals to minus 9 minus 6r. And we have already found out that OB equals to 3 over 2 times root 2. Okay, so we have the values of AO and OB, and AB actually equals to AO minus OB. Again, AB equals to AO minus BO. So AB equals to AO minus BO. So we substituted AO by its value, and we substituted OB by its value, and we found out that AB equals to this expression, and tangent theta equals to 1 over root 2. And we know that the radius of the small circle equals to AB times tangent theta. We have already found out the value of AB, and we found out the value of tangent theta. So we substituted AB by its value, and we substituted tangent theta by 1 over root 2. Okay, so we solved this equality, and we got to a quadratic equation. We got to this quadratic equation that 6r squared plus 72r minus 63 equals to 0, and we solved this quadratic equation, and the solution was that the radius of the small circle equals to 3 over 4 units, or the radius of the small circle equals to 0.75 units. Again, the radius of this small circle equals to 3 over 4 units, or to 0.75 units. Okay, thank you very much.